Hi students, welcome to Nated Lessons, and today we're going to talk about direct current motors. What do we know about motors? First thing you need to know about motors, they convert electrical power in, power out. They convert electrical energy into mechanical energy. So motors convert, the power in is electrical energy and power out is mechanical energy. So they convert electrical electric so they convert electrical energy into mechanical energy. So how do they convert? So this is the function of a motor. The function of a motor is to convert electrical energy into mechanical energy. But how do they convert electrical into mechanical? What is the operation of motor? So the operation of motor is based on armature reaction. It is based on armature reaction. Armature reaction is the distortion of main magnetic field entering and leaving the armature. So the operation of motor is based on armature reaction, which is the distortion of the main magnetic field entering and leaving the armature. Okay guys, so the magnetic field which enters and leaves the armature is distorted in order to get armature reaction, but there has to be a rotation in order for magnetic flux to be cut. So the whole operation of motor is based on armature reaction, which is the distortion of main magnetic field entering and leaving the armature. And then we come to the rotation. How does it rotate? So how does it rotate? So guys, here they enter the current carrying conductor. They enter the current carrying conductor in order to get a rotation so that the magnetic field can be cut into the magnetic flux. They enter the current carrying conductor in order to have the rotation. Okay guys, so still talking about motors. When there is electrical connection, guys, the current will move to when there is electrical connection, the current will move to magnetic field, to magnetic field. And move to the coil, or let me say, when there is current, when there is electrical connection, the current will move to the coil, to the coil field. You know, it will move to the coil field within the magnetic field. It will move to the coil field within the magnetic field. That will produce, which will produce which will produce magnetic flux or magnetic lines of flux. It will produce the main, which will produce main magnetic flux, magnetic lines of flux, let's say lines of flux. It will produce the main magnetic lines of flux, and still, when there is electrical connection again, the current will also move to armature coil, armature coil, which will produce secondary magnetic flux or lines of flux, secondary magnetic lines of flux. So guys, when there is electrical connection, the current will be excited into the coil, into the field coil within the magnetic field, and that field coil will produce the main magnetic flux. It will produce the main magnetic flux, while when the current moves into the armature coil, it will produce secondary magnetic flux. Know that it's gonna produce secondary magnetic flux. Okay guys, and the produced magnetic flux, the main magnetic flux, plus secondary magnetic flux will interact. They will interact. They produce the main flux, this within the armature and the coil field, or the field coil. They will interact with each other. So the main magnetic flux and the secondary magnetic flux will interact with each other. Hence, I say the main magnetic flux plus secondary magnetic flux, to show that both of these will interact. They will interact with each other, and when they interact with each other, they will create motion within the armature. They are going to create motion within the armature, and that motion will create the distortion or weakening. Distortion or weakening. Which will create the distortion or weakening of main magnetic flux, which is armature reaction. So the main magnetic flux and the secondary magnetic flux will interact, and when they interact they will create motion within the armature, and that motion within the armature will create the distortion or the weakening of the main magnetic flux, which is the armature reaction. And now we're going to talk about flow, guys. So main magnetic flux flows from north to south within magnetic field. So main magnetic flux flows from north to south within the magnetic flux, while the secondary magnetic flux uses Fleming's right hand rule. It uses Fleming's right hand rule. The main magnetic flux flows from north to south within the magnetic fields, while the secondary magnetic flux uses Fleming's right hand rule. And guys, magnetic flux doesn't matter if it's main or secondary. Remember, main is created by field coil, while secondary armature coil or conductor. So magnetic flux, whether it is main or whether it is secondary, when it interact, when these two, this one and this one, interact, let me write it here. When the main magnetic field and the secondary field interact, they cannot intersect each other. They will not intersect with each other, but they will stretch. But why will they stretch? They will stretch because they behave like elastic bands. Know that magnetic flux behave like elastic bands. So when they interact with each other, they will stretch. they will stretch, they will not intersect. Remember, they will stretch because the magnetic flux behave like elastic bands. Last but not least, about the operation of motor, it is this: the direction of the distorted magnetic flux. So the direction of distorted, sorry about that. So the direction of the distorted magnetic flux will rotate at the direction, it will rotate on the direction we got from using Fleming's left hand rule. So the direction of distorted magnetic flux, meaning the direction of the armature, the direction of the armature reaction, the direction of armature reaction will depend on Fleming's left hand rule. Remember that the direction of distorted magnetic flux or armature reaction will depend on Fleming's left hand rule, while the direction of the armature magnetic flux will be Fleming's right hand rule. Remember that. Okay guys, so let's talk about armature reaction in generators. Remember guys, when we talked about armature reaction in generators, it was causing the load characteristics, the load characteristics to drop from both separated till series and compound or shunt generators. Remember that. But armature reaction in generators, look at this, it doesn't depend on armature reaction for rotation, but it uses what? External forces. Remember this time, remember the one that uses external forces, it was separately excited generator, right? It does not depend on armature reaction for rotation, but it depends on external forces. Even if it depends on external forces, armature reaction still has effects on generators, which causes the decrease in magnetic flux. And if there is a decrease in magnetic flux, that means the load increases. See, the effect of armature reaction in generators, it decreases the magnetic flux, and when we decrease the magnetic flux, we increase the load. And as the result of the effect of generator, as the result of effect, as the result of effect of armature reaction on generator, it will cause the EMF to decrease. It will cause the EMF to decrease as load current, as load current as load current increases. As the result of effect of generators, the EMF will increase while the load current increase. Remember the armature in generators, generators that does not depend on armature reaction for rotation. It depends on external forces, but armature reaction still has effects on generators which will decrease the magnetic flux, and if the magnetic flux decrease, then the load will increase, and as the result, the EMF will decrease while the load current increases. And now let's talk about self-induced EMF, which is also called back EMF, which is also called counter EMF, but it all means the same thing. It's either you call it self-induced EMF or back EMF or counter EMF. What causes it is the rotation in the armature. There will be the rotation in the armature, which will be which the armature conductors will cut main magnetic flux to create induced EMF. So this is how that EMF is created. There will be a rotation in the armature, which the armature conductors will cut the magnetic flux, and this will create the induced EMF. This induced EMF, it is used to make this self-induced EMF, back EMF or counter EMF. It is used to make self-regulating motors. That is why it exists. It exists so that the motors can be self-regulating, guys. And to add more on this, the direction of self-induced EMF, back EMF or counter EMF, its direction opposes that of applied voltage. Know that the direction of self-induced EMF or back EMF or counter EMF, its direction opposes the direction of the applied voltage.